And the conjecture that we're trying to prove is that exact equations should be easier than the other methods. And yeah, that's generally speaking true. It takes a little bit to eyeball an exact equation. First you have to kind of put it in this form, right? And then you're kind of thinking to yourself, alright, if, big if, there was some function of x and y that was my solution, right? So I had this implicit solution, f of x and y is c. If I differentiated both sides, on the right I'd get 0, right? On the left I'd get whatever the heck the derivative of f is. So you'd like go hunt down the chain rule, and you'd be like, alright, so that's the partial with respect to x dx, plus the partial with respect to y dy. Okay, so if something like f solves my differential equation, that means that this should be true. Right, so I'm like, okay, so what do I got? Well, I got a dx, right? Dx. So that means I'm looking at this whole bit here and thinking this whole bit is like the partial of f with respect to x. And then this whole bit here is like the partial of f with respect to y. And then you're like, but wait, Clairaut's is a thing? So if there was a reasonable function like this, then the cross partials would be equal, right? So to check for exactness, you just literally hope Clairaut's at it and check. And so you're like, okay, so I'm going to take all this crap, my 3x squared cosine xy minus x cubed y sine xy plus 4x, and be like, alright, I'm going to hit that with a partial with respect to, good, you got to use y, right? Because you already kind of hit it once with x. So now hit it with y, see what you get. This one I'm going to hit with respect to x. And then I'm just going to wonder, are those two things equal? If they are, then I can proceed at trying exact things. If they aren't, then I'll quit.
Why did you pick those specifically? Because it kind of looks similar?
What's that? Oh, like where did this equation come from?
Well, no, like you picked the x cubed y and then the x to the fourth.
Oh, no, the whole thing.
Oh.
Yeah.
Like saying just
that whole thing and this here whole thing. You're getting all so cool when we were doing just the easy bits.
Just this thing and just that.
Yeah, just take the middle one. So in this term it's the middle one. And over there it's the right hand one, and that's how it always goes. Write that down.
People in the video are like, what?
And that's why you shouldn't skip around in videos. Alright, so I need the derivative of this whole thing with respect to y.
Okay, but didn't you say there was a thing where you could do like the easier one and then like check back it?
Yeah, that's if you know it's exact.
Oh, okay.
I don't know. I didn't get
In order to even start that whole process, you should check to make sure that it is exact.
Gotcha.
Right? Because if you like start, okay, so this is the x partial, I'll just integrate this with respect to x, and then I'll like integrate this with respect to y, and then try to mishmash. Like, well, it might work. It might just be confusing. If you don't check, you don't know whether it's going to work or not, and so you kind of have low confidence.
Gotcha.
So partial with respect to y of all this crap is a 3x squared.
Yeah.
Derivative of cosine is,
Sine y.
so I got a minus sine
X.
of xy, and then a derivative of the inside is x. And then here I need a product rule.
One stuff.
differentiation by parts.
Differentiate by parts. Yeah, pretty much. So derivative of the first thing with respect to y is x cubed times the second is sine of xy, and then plus the first thing, so x cubed y times the derivative of sine xy
Cosine
is cosine xy, and then there should be another factor of y in there. And then the derivative with respect to y,
Wait,
4x.
What did you just do?
Back up a second.
Sorry.
Why did you just do that?
You multiplied by the derivative
So I did.
inside of the cosine function.
The derivative of sine is cosine at the inside times the, oh, I did it wrong. Should have been an x.
I was like, wait, you did one thing at the
Sorry.
beginning.
My bad. Thank you.
Okay.
Good catch. Alright, and then the 4x's derivative is 0
With respect to y.
with respect to y. Right, so the 4x drops. And then on the other side here, you got a 8y's derivative with respect to x is
Nada.
0. And then I got a, ooh,
Can I ask a question real quick?
yeah.
So you know sometimes when you like slap a x on there or something, is that when you're integrating? Like you know how it's like or
Yeah.
8y right there? Yeah, okay.
So differentiating with respect to x, here I need the
The
Product rule again.
product rule again. So I got a minus, derivative of the first thing is 4x cubed times sine of xy. And then you need
By the thing.
plus x to the fourth times sine's derivative is
Sine.
cosine of xy times y.
Why?
Good. Okay, and then we're wondering if these two things are equal, right?
Ooh, I see some things that are similar.
So yeah, I see some stuff that's like kind of similar. So here I have a minus 3x cubed sine xy, and then I have another one, minus x
Oh, it
cubed
works.
sine xy, and a minus x to the fourth y cosine xy. And on the other side, I have indeed the same thing. Okay, so what have I accomplished thus far?
It's exact.
Yeah.
You can start doing
So-
it now.
Yeah, exactly. This means that you should try exact. If you came out with it's not exact, what do you do?
Very
You tried it anyway.
Double check your derivatives, right? Because I would have screwed that up. And then after you've double checked the derivatives, maybe try something else. Like rearrange this thing into dy equals stuff and see if it's separable, maybe, or first order linear, or
Oh.
whatever.
And me and Jordan did some Googling. If it's separable, it's always exact.
Yes.
So that one problem where it was separable, I just screwed up.
Oh.
Yeah.
It's been a
Yeah,
while.
I think one of the later problems is to show that separable and exact are roughly
The same
thing. Okay, so then what?
Then we go ahead and take derivatives of, not derivatives, inverse derivatives.
Yeah.
The simpler one.
So you got to here somehow, right? So you're like, okay, I'm looking for this capital F function. It's got a y derivative of this crap and an x derivative of this crap. You could try integrate this with respect to x. I'm probably going to look at that and be like, hey, I can integrate that with respect to y pretty easy.
Oh, because
You wouldn't do both?
Because they're the
Well, then you
same
can do
thing.
then
I
you can
might.
do a little shortcut thing.
Yeah, so you might do integrate this one with respect to x, integrate that one with respect to y. I lied to you earlier when I said I always do that.
He told me to do it the hard way. I see how it is.
Because on this one, it's going to be a mess. I mean, it's not impossible, but it's going to be a mess. Because, like, integrate that with respect to x is going to take a couple parts, right?
Or
Yes.
So, I'm going to integrate that with respect to y.
Four.
And then you do it on the left side, and it's
Yeah.
3 more.
So, I'm going to kind of hypothesize, right, that f is kind of like, right, I'm just like making up a symbol here. But like f is basically the antiderivative of 8y minus x to the fourth sine xy with respect to
Why?
y.
Well, can't you say that because they're exact, because you're like, yo, they're exactly the same thing, so I'm gonna do the one that's easier?
Yeah. So exactness tells you that there is some function capital F that you differentiated with respect to y to get this and with respect to x to get that. You could pick either of these to anti-differentiate. Because this one looks so much easier and the other one looks so terrible, I'm going to pick this one.
It's like variation of parameters.
If they're both kind of medium, I'll do them both and then just sort things out. This is going to yield a differential equation that I have to solve. The other way doesn't. Whatever. So, integrate this, you get 4y squared, I think. And then for your other bit,
You gotta part it.
what now?
Don't you have to do parts, maybe?
No.
Come on.
Oh, wait, no, those are constants. So it's x to the fourth y?
So, okay, minus x to the fourth, the integral of sine xy dy, right? Then you're like, alright, so how do you integrate sine of 3x?
Oh, just divide, so negative x cubed.
Yeah, really you should be thinking u substitution, right? So you let u be xy, and then du is, keep in mind you're differentiating with respect to y, x dy. Okay, so I need an x in here, right?
So you got 4.
But luckily I have a stack of them out here,
On deck.
Cosine.
so I'm gonna do something like that, right?
Oh, it's positive x cubed cosine.
So I got that this is 4y squared minus x cubed, and then I need to integrate sine of u to u. Sine of u's antiderivative is negative cosine, so you got 4y squared plus x cubed cosine of u,
X, y. Just
and u was xy, right?
plus the tangent.
And nice, plus constant.
Okay,
Okay, but constant,
With respect to y.
yeah,
So it's in terms of
I
x.
see sub y.
so it's constant with respect to y, so it might depend on x's.
Okay, I wasn't getting, that was the one thing in the videos that I really kind of was like, what? Because if it's just a constant, why does it?
So,
Because you always like ended up like slashing them or putting them together in the end anyways.
yeah, so I'm gonna end up using that to maybe make up for something here. Specifically, that constant with respect to x is where this 4x came from. The reason I know that is if I differentiate this stuff with respect to x, that piece goes away. This piece you need a product rule, and you get this thing and that thing, right?
Oh,
And then this
so
4x
right.
came from
That's
someplace.
gotcha.
And specifically that 4x came from here.
Gotcha.
So that's really your next step, is to be like, okay, so this is maybe what f looks like. But I know a little bit more stuff about x. I know that f has, this thing is its x partial, so I can do one better. So I hypothesize f looks like this, right? And then I calculate a partial with respect to x of this thing, and I get that f's x partial is 0 plus,
Squared cosine of xy plus x to the fourth. That should be negative. Yeah.
yep,
Xy.
so a little differentiating, right, product rule, little chain rule, will get you to here, and you're like, okay, cool, so that guy's the same, and,
No.
ruh-roh. What'd you do, Nye?
Yeah.
Oh, I didn't finish it.
So, I need this thing, right?
Oh. did
X
we-
partial.
Oh, we didn't multiply by cosine.
So, you get x cube's derivative times cosine of the stuff.
Yeah, y is constant, so.
I got that. And then you get x cubed, right?
Oh, are we doing partial with respect to x? My
Yeah.
bad.
Oh,
My
yeah,
bad.
and then there's another line.
So that's x cubed, right?
Yeah.
And then the derivative with respect to x of cosine gives me a minus sine of some stuff,
An extra y.
and then the derivative of xy with respect to x is y. Okay, so check, check, and the 4x is still unaccounted for, and it came from c prime of x, right? You guys see that? So this was what I was saying, you get a differential equation out of this if you don't do both antiderivatives.
Right.
Like if you do both antiderivatives, then you can kind of play this mix and match game. If you don't, you get another differential equation. Luckily, this one's not hard. Right? You just get c prime of x is 4x. So c of x is,
Yo, what the heck did you do?
No, he said, so your constant, you
so
said.
it's like there's a c prime over here, right?
Yeah.
And up here, in the thing it's supposed to be equal to, there's a 4x. Everything else is accounted for.
I thought you were just pulling some magic real quick. I'm just gonna guess that it's 4x.
No, I'm just like mix and matching, right? I'm like, okay, 0 accounted for, 3x squared cosine x accounted for, minus some crap and a sign, got it, and 4x meets c
2x
prime.
squared.
So c is 2x squared
Plug that on C.
plus an honest constant,
Gotcha.
right? Like plus number, right?
Right, no more letters attached to it type deal?
Yeah.
Gotcha.
And then take that and go where with it?
Oh, right back into F, right?
Yep. So this guy goes back in there, and then this guy goes into there.
That's the answer.
And so in the end here, I get a solution that looks like 4y squared plus x cubed cosine xy
Oh, suck the number in.
plus 2x squared, and then you're like, plus a number, I guess, is some other number.
And you can just say that's gonna be from number.
Subtract that over there.
Wait, minus number is 0, right?
They're arbitrary constants and different ones. Right, so really, that's bad notation, so we put a C, and then we circle this and move on with our lives.
Nice.
Because you probably can't solve this conveniently. Right, so you're like, okay, it's an implicit solution, I guess.
Plug it into the computer and have a nice day.
Yeah, this thing probably miserably fails the vertical line test.
You don't say.
I do say. Does that process kind of make sense?
Yeah.
Like this one was messy, right? But sorry, I lied to you, right? My bad.